What is up, math superstars? In this edition of Mr. Peterson Presents, I'm bringing to you Objective 6.15, the measure of center. So in determining the measures of center, we're going to take a look at part 2, which is deciding which measure of center is appropriate for the given purpose. And so we're going to cover some different definitions here, give you some examples, and after examples, we're going to do some practice with this. So our first word here is the word mean. So we talked a lot about that in part 1. So mean is the average of the numbers in a data set. And so these are numbers that when we take a look at them, they're all pretty close in value, but we have to see them in some different formats. So our first way is we're looking at the stem and leaf plot. And so with this, what we have to do is we have to determine how to read the data here. And so in our stem and leaf plot, the stem represents the values that are going to be in the tens place, and the leaf are values that are in the ones place. And so when we write out our data here, so we have 72 plus 72 plus 74 plus 77. And then we keep going, so we have 80 plus 84 plus 87 plus 87 plus 87. So we get the point here. So all the way down now till we reach, so we have 10 and some zeros here. We have 3 students that scored a perfect score on whatever test this was. And so what we have to do pretty much is we have to find out all the values, we add them all together, and then we divide by the total values that we have here on our chart. So after we added them all together, we would divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we'd have a really big value. We divide it by 20, and that would give us the mean, which is our average from this stem and leaf plot. We can also determine the mean based off just values on a regular line plot. And so if we were to label these numbers, say we started with, say this is 6, then 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. What we would do is we would have to write out all the values that we had here in our line plot. So we'd have 6, and then here for 7, it's listed twice, so we write 7, 7, then 8. There's nothing on 9. So then 10 has 3, so we write 10 3 times. And then 11 2 times. And then 12. There's nothing on 13, so we write 14 twice. Nothing on 15, and then 16. And so just like we did in the example before, we would have to add up all these values together, and then we would divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And so then we divide by 13, and that would give us the mean value for our line plot. Another word that we're going to take a look at is called the median. This is the middle number in a data set. And so we use the median if there is a much higher or a much lower value in our data set. And so we call these numbers, they're called outliers. So it's important, please write that down in your notes. They're called outliers. So we'll see some examples of those and how the median works. So we have our stem and leaf plot. So our first step now is we need to determine if there are any outliers. And so here we can determine that 45 is going to be an outlier. We can say that because we have all these values here are between 70 and 90, and our outlier is at 45. So whenever we have an outlier, we're going to use what we call the median. So the median is the middle number. And so using our stem and leaf plot, what we're going to do now is we're going to figure out which one is our median number. So we're going to cross out numbers as we go along. So we're going to start with our lowest value, which is 45. And we're going to cross it out with our highest value, which is 98. Then we're going to go our next lowest is 70. and then our next highest is 98. And we're going to keep going on with this process. 74 and 93, 74 and 93, 78 and 93, 78 and 93. And we're going to keep on going. 82 and 88, 82 and 87, 85 and 87. And then we have two values left in the middle. And so whenever we have two values left in the median, what we do is we take those two values. So we take 87 plus 87, and we divide them by 2. So in this case, obviously it comes out to 87. Nice and easy. Sometimes it will give you a decimal there. Sometimes it will give you a number. Whatever the average now of these two numbers that are in the middle will be our median. Sometimes it'll land you right on a number without even having to do any math. So it might land on 7, and then we just write 87 is our median value for the measure of center. So we can also take a look at it here with our line plot. So our line plot, first up is we're going to identify the outlier here. So we have our X right there. And so if we were going to label these, so let's go ahead and label these 6, 7, 8, 9, 10, 11, 12, 13. I'm just labeling my number line here so we can see these values. So we have values that range between 6 and 13, but we have our outlier. This is going to be our highest number. We call this is our outlier. So now we need to figure out the median. As soon as we figure out we have an outlier, we're going to go to the median. So now we're going to go ahead and cross out values now. So we're going to start with our lowest value and then work with our highest value. So we're going to cross out, here's a 6. We're going to cross out the 22, two highest. So now we're going to go, the next one is 6. Then our next highest is 13. And then 7 and 13. Then our next lowest, 9 and 11. And then we're going to do 9 again and 10. And then 9 again and 10. And now we're left with two values. So we're left with 9 and 10. So we're going to add these together. 9 plus 10 equals 19. And when we divide them by 2, it equals 9.5. And so our median value here for our data set is 9.5. So another way we can do a measure center is the mode. This is the number that appears most in the data set. So when we take a look at our stem and leaf plot, we're going to figure out which number appears the most amount of times. And so we can have 74, we have 74 is listed twice, 78 is listed twice, we have 82 listed twice, okay? We have 87 listed 4 times, okay? We have 93 listed 4 times, okay? And 98 is listed twice. So here our mode is two numbers now. So our mode is 87 and 93. And so if we have two numbers that show up the same amount of times, this is called bimodal, because we have two numbers that show up the same amount of times. So once again, we have our line plot. So we're going to label our line plot here to make it easy. 6, 7, 8, 9, 10, 11, 12, and 13. And so now we need to figure out which number shows up the most. And so we have 8 shows up 3 times, and 11 shows up 3 times. And so we know that the mode for our data set is 8 and 11, and this is called bimodal. And so the mode works really well if you have any kind of surveys. Anything we have a yes and a no to, we can figure out the mode really easy. So We have question number 1 says, I studied for this test as much as I should have. So we have 19 students that said yes and 7 students that said no. And so we have my score reflects that I studied enough. 10 students said yes, 16 students said no. And I will study more for the next test. Of course, 22 students said yes, and then you have 4 students that said no. So we'll give them a sad face. Sad face. Okay. So if we figure out the mode of our data, which one shows up the most here? So we have 22 students would be our mode for studying more for the next test. So the mode also works well if you have some data in bar graphs. So we have a bar graph and we have a circle graph. And so for students' favorite color, if I asked you for the data, for the measure of center, for students' favorite color, we can sit there and say, look right here, we have green, or is the color that students chose most out of the bar graph. And when we look at the circle graph here, so we have, once again, green is the biggest piece, and so we can say that the most students chose green, and the word we use for most is the mode. Now range. The word range here is the difference between the smallest value and the largest value. So here we have determined the range of this stem and leaf plot. We're going to take our smallest value is 45, and our largest value is 98. And so in order to determine the range, what we do is we take 98 minus 45. So we can say that the range of our data set is 43.